Hello friends, in this video we will be talking about AC applied to pure inductance. Okay, in the circuit I have a source of AC EMF and an inductor attached to it. Now if there are any resistance or capacitance effect, we have to completely neglect that. Okay, so the first equation is of voltage V equals to V0 sin omega t. That is forming equation 1. Now you know that whenever applied EMF is given to an inductor, there will be an induced EMF which is generated. And what is that induced EMF? Epsilon is equals to minus L di by dt. Now when the switch is turned on, then after some time a steady situation is reached in the circuit. Okay, the current reached a steady condition, and in those steady conditions the applied voltage and the induced EMF will be equal. But you know that induced EMF will always oppose the applied EMF. So V is equals to minus epsilon. Epsilon is what? It is the induced EMF. Okay. So putting the value of epsilon in over here, minus L di by dt, minus this becomes plus. So what is V? V equals to L di by dt. Okay, I need an equation which can connect voltage, inductance and current. Voltage, inductance and current. So this equation has that connection: voltage, inductance and current. Okay, I need to find electric current. So rewriting this equation for di, that is V by L dot dt. I don't want to find the small fraction of current, I want to find the total current. So I am integrating this di, that means this has to be integrated. Integration of V by L dot dt. Now, putting the value of V, what is that? V0 sin omega t by L into dt, because V0 and L are constant, they can be taken out, and sin omega t dot dt ka integration kitna hota hai? It is minus cos omega t upon omega. So omega, because it is the frequency of applied AC, so that is constant, that can also be taken out. What is left in the bracket? Minus cos omega t. Okay, now again there is a need of comparing voltage with current. So for the comparison, I have to change this cos function into sine function. Again, I can do it with two different ways. I am having minus cos omega t, so this is minus cos omega t will be equal to minus sine pi by 2 plus omega t. ये कैसे होगा इसको जरा देख लो. See, on the RHS I have minus sine omega t. Okay, so when I take this sine inside, this will be minus omega t and minus pi by 2. अभी ये वाला फिर से यहाँ पे काम नहीं करेगा. क्यों नहीं करेगा? Because the phase of sine will be minus omega t. Here the phase in the voltage is omega t. I have to make both the phases of the same sign. ये plus omega t है, तो इधर भी plus omega t मुझे चाहिए. Alright, now how to convert this? See, sin omega t minus pi by 2 is cos omega t. ठीक है, देखो sin pi by 2 minus omega t will be cos omega t, but sin omega t minus pi by 2 will be minus cos omega t. Okay? So this replacement, the second one, I am doing it for here, and the equation changes to minus cos omega t ki jagah sin omega t minus pi by 2. This is the equation of electric current. Right? Now here again, in the denominator, instead of L omega, I am writing XL. What is XL? XL means inductive reactance. What is it? Inductive reactance. See, current is equals to voltage upon resistance. यहाँ पे resistance की जगह जो भी होगा वो क्या करेगा? Current को oppose करेगा. Okay. Here XL is opposing current. That means L omega is opposing electric current. I cannot call it as resistance because resistance has a different reason, and this quantity has a different reason to oppose electric current. V0 upon XC. Now what is this V0 upon XC? It is equals to the maximum current that is flowing in the circuit. Okay, right? So this is the final equation for electric current. Now coming to this XL. XL is equals to L into omega. What is omega? 2 pi f, converting angular frequency into simple frequency. So XL is directly proportional to f. As you increase the value of f, xl will also increase, so the graph is a straight line. Now drawing the phasor diagram. सबसे पहले equation of voltage is given to you. So draw any phasor. ऐसे कुछ भी करके कहीं भी एक voltage का ऐसे phasor बना दो and just write down omega t. Now the phasor of current. You can see the phase is omega t minus pi by 2. यानी जो भी voltage का phasor है उससे आपको 90 degrees pi by 2 रेडियंस कहाँ जाना है? क्लॉकवाइज डायरेक्शन में. नेगेटिव साइन है तो क्लॉकवाइज, पॉजिटिव साइन हो तो एंटी क्लॉकवाइज. सो फ्रॉम हियर आई हैव ड्रॉन द फेजर ऑफ करंट विच इज 90 डिग्री बिहाइंड इट. इसका मतलब क्या हुआ? दिस मीन्स दैट इन एन इंडक्टिव सर्किट हु इज अहेड, वोल्टेज इज अहेड. Who is behind? Current is behind. How much behind? By a phase of pi by 2. All right, now the final thing, the graph of current and voltage. Very simple. The graph of voltage is the similar graph to sine function. So this solid line, this is the graph of voltage. And now the graph of current. You can draw the graph of current from here. यहां से भी आप करंट का ग्राफ बना सकते हो. साइन ग्राफ बनाओ, लेकिन उसे जीरो से शुरू करने के बजाय उसे स्टार्ट करना है माइनस पाई बाई 2 से. ओके या फिर आप ऐसा कर सकते हो, हियर इन दिस इक्वेशन ऑफ करंट आप माइनस कॉस फंक्शन का ग्राफ बना दो. माइनस कॉस का ग्राफ, कॉस फंक्शन का ग्राफ कैसे होता है? पॉजिटिव से शुरू होता है, फिर नेगेटिव एंड देन कमिंग बैक टू पॉजिटिव. माइनस कॉस का ग्राफ कैसे होगा? स्टार्टिंग फ्रॉम नेगेटिव, गोइंग टू पॉजिटिव एंड फाइनली अगेन बिकमिंग negative. This is the graph of current and voltage.